All right. Starting the recording, this is one of the problems we left off for applying the fundamental theorem of calculus. Right, Andrew? Right? Okay. So the steps are there, but I turned it on late. So hopefully, staring at that, you see where everything came from. So now I do my addition. It's not a bad idea to think of, you could use a calculator straight across if you want, but I'm not picking it up, because what if it wasn't a calculator problem? I'm going to write this as a -2 plus a 27 all over 6. Remember that trick we did in the old days? Minus, I know what a half plus 2 is. That's 2 1/2, which is 5 halves. -2 plus 27 is 25 over 6. I may as well make this into 15 over 6. That way I can, without a calculator, know that the answer is 10 over 6, and when I reduce it, 5/3. It'd be nice to know if somebody had done this without me, without my help, and got the same answer.
Wait, sir, what was this?
Thank God. Say it again.
What was
The trick of adding or subtracting fractions, you start bottom right-hand side,
okay.
corner, multiply straight up. That's a -2. Come to the other bottom, left-hand side, 27. So that sign's here plus, so I go plus 27. And then I multiply those two denominators.
And how do you get 5 over 2?
1/2, that's plus 2 is 2 1/2. 2 1/2 is 2 halves plus a half. Maybe I'm wrong. No, it's 4 halves plus a half, 5 halves. Okay, you want to do the trick? Let's try it. Let's see. Maybe I'm wrong. But Camilla got the same answer, so I don't think I'm wrong. 1 times 1 is 1. 2 times 2 is 4.
Oh, yeah.
All over
Wait, 2.
2. 5 halves. All right. Bottom of the page. Should there be a rewrite? There should be, because unless it's du over u, which we haven't really had that come up that much, I don't think the numerator is the derivative of the bottom. Do you? No. So I'm going to do a rewrite. 1 over 4 of 2x over x squared, plus 3 over x squared, all dx. That simplifies even a little more as, oh, wait a minute before I do it. Remember what I said to you about checked fractions? Is there a chance that the top is the derivative of the bottom?
Oh, yeah. Yeah.
What would that imply? What would that integral be, the antiderivative be? Natural log of? Why 2? That 2 is part of the derivative of the bottom. U equals to x squared. Du equals to 2x dx. There it is. There's my 2x dx. So that 2 gets absorbed by the integral monster. You don't really have it. So that is the natural log of x squared. Remember the other day I said we should put... I didn't rewrite it again. I left it for a reason so you would see this. Now, I know what you're thinking. Your answer looks different, but the property of logs say they're the same. The natural log of x squared is 2 natural log of x.
Oh, yes, that is true. Yes, it is.
So, I just didn't do the rewrite because I said, oh, I wonder if it's already good enough. I just got lucky, Joseph. I just got lucky.
Wait, so is it okay to put as 2 natural log of x?
Sure is. Sure is. And then the next part is it possible that 3 is the derivative of x squared? No. That's really x to the -2. So that gives me plus 3 x to the -1 divided by a -1. You lost that?
No, I'm good.
Oh, you're good? And that's going from 1 to 4. Oh. So here I go. Get ready for my parentheses. Put a minus, parenthesis. This is not very pretty. It's okay. Plug in the top number. In my case, I have the natural log of 16 plus. That really becomes that minus, I should take off that plus because that minus actually turns this into a minus right here, doesn't it? So it's minus 3x to the, oh, it was a squared, wasn't it? Oh, I'm already, why am I integrating again? Hello. It is minus 3 over x minus natural log of 1 plus 3, why I got an x? What was I supposed to plug in? Somebody tell me. I was plugging in a 4. Natural log of 1 plus 3 over 1. Actually, it's a minus again, isn't it? Where is that? I want to get rid of that. How long ago was that? There it is. Oh, wait, come on, come on, come on. Come on, take it. Oh, it's not taking it. Let me just delete it. Nope. Don't do that. Never mind. Dahlia.
I have a question.
Oh, okay, yes.
Okay, you know the 2, where does it come from? Like on
Where?
X,
Where?
Squared. Like the step before.
Here? This 2?
No, no, no. Like, you know
This
how
2?
2x minus 1, like you can't add 1 because they don't become 0?
Where are you getting 2x minus 1?
Like, but that's the rewrite.
Where the rewrite was not 2x minus 1. There's no minus 1 in there. It was
Yeah.
2x over x squared and a 3 over x squared.
Yeah, but isn't it like 2x, and then because it's being divided by x squared, don't you like subtract 2?
Subtract 2.
Not only the book divided by x squared.
Yeah, yeah, yeah.
So you just separate.
You could have turned it into 2 over x. That's what Joseph did.
You just separate.
That works too. But then he still left 3 over x squared. You can do that. But when you integrate it, it's still going to be, now it's still 2 natural log of x, which is the same as that. Because the power, you can move the power to the front. Properties of logs. That's where that 2 would have come from Joseph. Joseph. Yeah, you have to know the properties of logs. Yeah, I think the sheet I gave you had it, though, the formulas. Take a look at it. I think it should be there, I hope. Anyway, I'm back again plugging in the 1. That's a natural log of 1 squared, which is 1. It says a plus, but it's actually a minus. It's actually a minus. So I'm going to go minus 3 over x becomes 3 over 1, which is minus 3. Now I'm going to take off all the parentheses. Natural log of 16 minus 3/4 minus natural log of 1 plus 3. Can somebody tell me, does anything go away? Is anything there equal to 0?
Yeah, natural log of 1.
Okay, so that goes away because that's equal to 0. So it's gone. So I'm just going to write it like this. Natural log of 16 minus 5/4 plus 12/4. And by the way, AP test, you don't have to do this.
Wait,
You
so you're
could-
going to leave it in terms of natural log?
I am.
Oh.
Yes, I don't want to turn it to a decimal. So I'm allowed to do this. You don't have to. You want to type it in the calculator, you can. And I'll get Joseph's answer in a second. Minus 5/4 plus 12/4 is 7/4. This answer is perfectly good. You are allowed to leave the answer like this. And if you didn't have access to a calculator because it was non-calculator portion, you'd have to. But because Joseph is the kind of guy he is, he has my answer with 3 decimals. What'd you get?
I got 5.0022.
022. I have no reason to believe that he's not right. Both?
Accuse him.
No.
So,
That was the hardest one so far.
I don't get that problem.
So is that 704?
Yeah.
I get with Joseph.
Wait, sorry, it's 4.522.
4.5.
Okay, so you want me to change that?
Yeah.
4.522. Did anybody get 4.522 or natural? You did by hand?
In the calculator.
With the did anybody get natural log of 16 plus 7 fourths? Camilla, are you okay with our answers? That was the hardest one. That's the one you would want to do a second time. Oh, yay, our friend Trig.
Oh,
Oh, no. It's okay, guys. There's no rewrite. The integral, the antiderivative of 2x is 2x squared over 2. That cancels out the 2, x squared. The derivative of what is cosine?
Oh, negative, negative sign?
Is it negative?
No, it's sign.
It's just sine. That's right. See, that wasn't that hard after all. All evaluated from 0 to pi. So there are my parentheses. Plugging in the pi. Pi squared plus sine of pi minus 0 squared plus sine of 0. Does any of that go to 0? What's sine of 0? 0. That whole thing's 0.
Oh,
So I am going to just leave my answer like this.
and 0 squared is 0 also.
Yeah. There's a perfectly good answer that the AP test will take. But I know Joseph, he loves decimal answers. So just in case you could use a calculator and you want
I
to,
get this. From that problem, I get it.
This one is easier.
this one is easier though, yeah. So did you do a decimal on this or leave this, Joseph?
9.
Yeah, you left it? Yeah, I'd leave it. Who cares what pi squared is? Nobody really cares. If they said they cared, they're actually lying to you. Okay. Do you all want to see it worked out again?
How'd you get the 5.4?
Let's just do it again in case there's a mistake. Maybe that's why you're questioning it. Here.
Because that was what? That was 7, because that natural log of 16 supposed to be plus.
Yeah, he had gotten a
9/4.
different answer. That's what you had gotten originally.
Supposed to be, that's what I got originally, but then you said it was 7.
Well, okay.
That's supposed to be 9/4, not 7/4.
Oh, this was 9. Where?
That's supposed to be 9/4.
I have 9 over 4. I do?
16 plus 7/4.
Oh, yeah.
That's supposed to be 9/4.
Page. It is? No, why?
Because
What's 12? What's 12 fourths minus 5 fourths? No, the question is, why is it a 5 fourths? That's what you're missing.
Why is it a 5/4?
That's what you didn't ask.
Why is it a 5/4?
Wasn't supposed to be. I wrote it wrong, and you didn't catch it. So it was a 3/4 originally, and then that would have been 12 fourths minus 9 fourths. Now what is that answer?
5.022.
Oh, then they're both right now. Either way,
5.022.
5. Yeah.
So it became a 3/4?
No, yeah, it was never a 5 fourths.
So what is it?
It's a 3 fourths. It's right there. I'm looking at it. Talia, what number are you on? Okay, but go over there and sit.
No, it's because he's helping me.
No, go over there. Get help at lunch. Because it's not just like a minute. The distraction is causing maybe us not to have caught this 5 and do a 3. Yeah, go sit over there. And just, because I know you can't resist the temptation to turn around. That's what we're all here for, together though. We're together. We're not doing homework. I didn't say go over there. That's not going to help you over there.
Yeah, but sir, I think she's done with the help.
Why do I keep asking? No, should not be any different. No, can I have what the original problem was again?
It was like
2x.
2x plus 3 over x squared.
So I wrote it as 2x over x squared plus 3 over x squared dx. Let me do what Joseph did this time to see if our decimal answer comes out the same. That becomes an integral of a 2 over an x plus 3 over x squared dx. When I take the antiderivative of 2 over x, that's a 2 on the outside. You could actually have done this, guys. You actually could have done this. This is not till the next lesson, actually, where we actually apply properties. But technically, that 2 doesn't get involved. That's why you heard Joseph say, it's 2 times. Well, it is. It is 2 times natural log of x. And this is still, that's an x to the negative 2, so this still becomes minus 2 over x, I think. Because it was 2x negative 2. Yes. That becomes a negative 1. Divide by negative 1. That becomes a minus. All of this is evaluated from, what were my limits? Yes.
Why did you have a 2 instead of a 3?
Oh, was it a 3?
Yeah.
I didn't see it. Right. Thank you. What were the limits? I never wrote the limits. Is the 4 on top or the bottom? So we say 1 to 4. Bottom, we start with the bottom. 1 to 4, 1 to 4, 1 to 4. From 1 to 4. Plug in the top first. 2 natural log of 4 minus 2 over 4. 3 over 4. Yeah. It was, yeah, it's a 3. 3 over 4 minus, plug in the 0. 2 natural log of, not 0, plug in the 1, natural log of 1, minus 3 over 1. There it is. That's 2 natural log of 4 minus 3/4 minus 0 plus 3. So if Joseph, I knew it. Oh, I can't charge at the same time. That's the problem. Well, here it goes. I'm going to have to, though. I'm going to have to take that off. Where are you? Oh.
Apple Pencil battery slow.
Yeah. I knew that was going to go because I didn't charge it this morning.
So you're not teach your fingers?
Yeah, I'm going to have to. I did, but I had to unplug the, I had my,
But it charges really fast.
yeah, it won't be bad. So, Joseph, can you key all that in? Do we get the same decimal? Is 2,
2 natural log.
why won't it write? Why won't it write? It's not liking my finger anymore. This happened the other day. It does this. Oh, there, 2 natural log of 4 minus 3/4 plus 3 is approximately what decimal, Joseph? Key that in. Drum roll. You can't key in 2 natural log of 4?
No, I can't do the drum roll.
Oh.
Like, I don't know how to do it.
5.022. You typed it in?
Yeah.
Is that what you said? The problem here it should be the same thing, unless some. What? This still is 12/4. Okay. We didn't have a 3/4? I'm learning. I only want Andrew. All right. Back to a table.
Wait, sir,
Yeah.
Go back to that number,
All right. Moving on here.
He's jealous.
Pictured below is a table of values that shows the values of f and its first and second derivative. We've seen those tables before. Interesting. How are we going to use it? Oh, okay. They're generic f's. We don't even know what the functions are. So let's see if we can wiggle through this one. If I'm integrating f, what is the answer that comes out?
F of X.
There already is an f there.
If you integrate F prime.
It's actually f prime, yes.
So it's going to be F of X.
It's going to be an f of x, that's right. Going backwards, right? So the answer here will be f of x from -3 to 1. In case you didn't see it, there is a prime there. You see that? When you integrate a derivative, it turns into the original function. So now that becomes small f evaluated at a 1 minus small f evaluated at a -3. Where do I get those values from?
From the table.
The table. What is f of 1 in the table?
-2.
-2 minus, what's f of -3?
4.
And that becomes a -6, I think.
Yeah.
All right, now he's getting harder. Look at that. He's throwing us an f prime and a double f prime. So when I integrate f prime, what's the antiderivative? What does it become?
F of X.
Everybody?
All together now.
All together now.
F of X.
And in my head, I'm spinning now that's done. I can leave that for a minute.
Prime of X.
It became f of x. And Bella, the next one becomes?
F prime of X.
Nice. And all of this goes from
Okay.
-1 to 3. Now there's two things, so be careful. When you make your parentheses, you know you have two things in there. So we got to make room. So it's going to be f of 3 plus f prime of 3 minus f of -1 plus f prime of a -1. And those values, I hope, are in the table, or else he made a bad problem. What's in the table of f of 3? 1 plus f prime of 3? 3. All of that minus, I'm going to put a parenthesis here so I don't mess up, f of -1. I'm sorry, it was f, yeah, it was 0, plus f prime of a -1.
1.
So that becomes 1 plus 3 minus 1, or 3.
Oh, I get it. So I get this.
Well, I like this. This piggybacks off of when we did derivatives that way. Remember with the chain rule, and all we had was an f of something, and we had to go. It's the same
But
thing.
this is better.
Well, this is showing you know the concept. This is very conceptual based, not mechanical.
You didn't know that which person?
How to use it from here?
No. Do you need to know like for like other questions, or is it just for this question?
Right now it's just for these. Practice. Huh? Yes. It's just practice. So what happens here? Does that 3 do anything?
No.
No. So it's going to be part of my answer. Did it again. 3. And when I integrate f double prime, it becomes f prime. From 1 to 5. Now, some people don't use the 3 in the whole thing. Some people put the 3 outside and then do this. That way, they don't have to write the 3 all the time. It's your choice, though. If you want to keep it in there, You can. You can actually do equals 3f prime of 5 minus 3f prime of 1. But then you're writing the 3 twice. And that's fine. You can do that. Some people factor it out and just do 3f prime of 5 minus f prime of 1. Either way is acceptable. What is f prime of 5? 3 times a 2 minus f prime of 1.
F prime is 1 is 0. Oh, F prime of 1?
0.
Let me look myself. F prime of 1, here's the 1. F prime is 0.
Is negative, oh, 0.
That becomes the answer of 6.
Easy.
Yeah, not bad at all. It looked scary when I first saw it. Now, I'm going to show you another property that may make your work easier. You don't have to do this. You can actually break this into 2 separate integrals if you want. Some people don't want to be plugging in so much at one time, so they break it into 2. Negative 3 to 3 of f prime of x dx plus 2 integral from negative 3 to 3 of f double prime of x. I'm just showing you, I'm kind of killing 2 birds with 1 stone. You can break that apart into smaller integrals. But then don't forget, you still got to do all the work. So that becomes, I hope they integrate, when you integrate f prime, it becomes what? F. F of x from negative 3 to 3. Oh, wait, I lost a half. Did you catch it? Did you know I lost a half?
Oh, yeah, I already put that.
I did on my paper.
Oh, you see, and I didn't have it. So that 1/2 is out here times that. I saw the 2, but I don't know why I didn't see that one.
Do you do the 1/2 the way you, I know you don't.
It's your choice. Do you want to break this apart in the next step? Do you want to spread it out or keep it just as one? It's a judgment call. Some people keep them together, but you got to keep it together both times. I'll probably pull it out. I'm an old man. It's hard to change my ways, my wicked ways here. So that turns into f.
I got the answer.
Well, you're faster than I am. F prime of x. And then, so if I pull out the 1/2, that becomes f of 3 minus f of a negative 3 plus, pull out the 2, that becomes f prime of 3 minus f prime of a negative 3.
Oh, you got the minus on there.
Oh, yeah, I said it.
Yeah, you said it. I think it says there's a little line in the
Yeah, maybe I did right. I just wrote over it. Thanks, though. Appreciate it a lot. What's 1/2? What's f of 3?
1,
What's f of negative 3?
4.
4.
That's 1 minus 4. That's a negative 3/2 when you negative 3/2 if you think about it. What's f prime of 3?
3,
What is f prime of a negative 3?
negative 2.
So that's 3 minus 2 is 1. 1 times 2 is just a 2, right? So negative 3/2 plus 2, I'll write that out here. Negative 3/2 plus 4/2, because I don't have a calculator. Ta-da! I hope it's 1/2. Is that what you had?
No, I did it differently.
No, but the same answer.
No.
We should get the same answer. So either I'm wrong.
No, I'm wrong.
Where would you be wrong?
I did it differently.
That doesn't make it wrong.
No. Like, my answer is not correct.
Well, did anybody else do it on their own without any help? A half?
Oh,
What was
I
the
didn't
answer?
get that either.
I don't know. I got a half. I don't know what the
Did you-
answer is.
Oh, it's because you put -2, but it's supposed to be minus 2.
Where?
On 2 parentheses 3 minus 2.
F of 3
F prime of
minus
3.
f prime of a negative 3.
Prime of negative
Oh, I didn't. You meant I dropped. You said f of a negative 3 is a negative 2, so you're right. So that really becomes a 5 times 2 is 10.
And then for the other one,
And that one too? Did I mess it up there too?
I think
Minus, minus? See, Adam, you might be right.
it's f of 3 is 1.
And
then
f of-
f of negative 3 is plus 4.
Oh, no, you
So
took,
no,
no,
you're
so I was right. I was right on that one.
You're right.
So what is 10 minus 1.5?
Negative 8. I mean, sorry, 8 and a half.
8.5.
Yes.
Ah, come on. Why won't you erase? Erase. Oh, good. 8.5. When I write 8.5, if I write 8, doing it again, come on.
That's what I got, sir.
8.5, that is 17 halves. Or 8.5.
Yeah, that's what I got.
That's what I got.
Good, okay. Thanks to Bella. She found my mistake. Okay. Did Cons give you any of those table problems?
Sort of.
They gave us
Sort of.
summation.
But it just said find the area.
They gave us
Yeah,
summation.
okay, same
Or
thing.
even tell us to
Wait, sir. I have a question. Are we gonna
No,
learn
no, it
that
didn't.
summation of each?
Oh, yeah. But we're not gonna hit it in the head so hard that it's perfect in your head, because the only thing you have to do on the AP test is recognize the correct equation for the summation. They're not gonna make you actually do it. Because what that is, it's sort of like, they're not gonna make you actually find the derivative using the limit as delta x goes to 0 of f of x plus h minus f of x all over delta x. They're never gonna make you do it, but they may have a multiple choice question where it's done for you and you have to recognize which one was correct. That's the same thing they do with that limit of the sum. So yeah, we will have to look at it. I have to go over it. What is the equation, the tangent line to the graph of f of x at x equals to 3?
Wait.
Why does that look weird? Why does that look like nothing in this lesson? What is the equation, the tangent line to the graph of f of x at x equals to 3? Oh, maybe. Because we're looking at 3, and I want the equation of the line here at x is 3. So I think she's right. They threw that at you just to say, do you remember y minus y1 equals the slope times x minus what?
I'm so bad at that.
Y m times x minus x1, which in terms of my problem, it's y minus f of 3 equals f prime of 3 times x minus 3. Isn't that bring back bad memories?
Are you doing that based off of number 3? I mean number 4.
No, I just did it by itself. He said f of x at 3. So now what I'm going to do is, why did I say y? It's not y, it's not y minus. It is, do our table have an f of 3? Does it? Does our table have an f prime of 3? Yep. So my equation is, help me out, guys. Guys, don't get lost yet. Y minus, what is f of 3? How much? 1.
Y minus 4.
What is f prime of 3?
3.
Times x minus 3. Is there anything else to do, or is that the equation?
That's the equation.
There's nothing else to do. That's the equation.
What was it that?
No, that's old stuff. It's spiraling in something from the past. You can't forget that.
If we have a unit test on this bracket, would you pull something like this?
Well, he will.
Would you?
Yeah. I mean, he has it. Yeah.
He makes it test.
Oh, yeah. Especially as we got a month left. Yes, everything's fair game. We've got to be thinking. Write the equation line in number 5. Is that what we just did? Yes. To approximate the value of 3.1. Okay, so you just did all the work to find the equation of the line. I really want to approximate f at 3.1 is approximately something. But you notice the table doesn't have any 3.1s, does it?
Use
Use the
that July.
He said use the one we did at 3. Well, it makes sense because isn't 3 close to 3.1? So we're using the equation of the line at 3. And this is a very important problem. I can't imagine that 5 and 6 would not be on any AP exam. Approximating a value when you don't have it in the table or you don't have any knowledge of it. So you got to use what you have knowledge of. Well, we did the 3. So that's going to be, the only bad thing is I got to rewrite this problem. I got to solve this. I got to write it like this. That means y equals to 2x minus 6 plus 1. 2x minus 5. Okay, so there's my equation, right? Same equation. Hello? Y 3. It's a 3.
What is it?
Y equals 3x
Minus 6.
minus not 6. No, it wasn't 6 either. It's a 9. Why didn't you catch that too? Plus 1. 3x minus,
Negative 8.
yeah, 8. So, I'm going to write it out here. It's going to be 3 times a 3.1 minus 8. That's right.
1.3.
9.3 minus 8, 1.3. There's your approximation.
It's an over approximation.
Then he wants to add, the question is this, and he didn't ask that, did he?
Yeah.
Is it over and under? How do you know it's over?
Because concave down.
Ooh, how'd you know it's concave down though?
Because the second derivative is negative.
Oh my God, give that guy a cookie.
Joseph, you want to go to
Concave
prom with me?
down.
Yeah, look at that table. The second derivative at 3 is, wait a minute,
Ask him, you know what's going on.
Yosef,
Wait, what?
the second derivative at 3 is not concave down.
Wait, is that not concave down?
Oh, okay, I was just fooling him.
April Fool.
April.
Oh, yeah, it is. Wait, we missed it. That was yesterday.
No, it's today.
Today?
Today's
Oh, you know why I'm confused?
Why?
Because I got an email this weekend to remind me that I have jury duty.
Oh,
And-
April Fool.
No, I really do.
When?
But I was thinking, oh, I got a long time to worry about it. It's tomorrow.
Oh.
And what other days?
April Fool.
You only know about one day.
But your math teachers,
April foolishness.
they're not gonna want you.
They never want me.
Teachers are smart.
But they still make you sit there and punish
Yeah.
you.
Place Sudoku for like an hour, sir.
At least he'll be a member of,
Literally ask.
you know,
Literally everything goes wrong.
Yeah, I know. But are there any big things in the news that could be tried?
Sir,
Okay. Joseph is right. Second derivative, because f double prime
Yeah, so over approximation.
is less than 0, it's concave down. So any tangent line at this 3, guys, you should all pay attention here. 3 is here. Any tangent line looks like this. So just think about it. If you were to go a little more from 3 to the 3.1, it would be on the line above the curve. So that value would actually be higher than the actual value, which would be on the curve.
But isn't it lower?
No, because the 3.1 was estimated from this line.
Yeah, but that line is like this. So if the 3.1 is here,
Well, the 3.1 is underneath the line. When your tangent line is on it, the whole function's below it. Every value's below it except for at 3.
so your approximation is higher than the.
Your approximation is higher
Yeah.
than being on the function.
Yeah.
Guys, this is definitely going to be on any AP test, any benchmark test, whatever. And I just can't believe that Joseph ran with it so hard and so fast that is so admirable.
Good job, Joseph.
All right, now, looking at the next. Yeah, oh yeah, because I'm done. These are all done. Oh, yeah, we didn't finish. How much time we got? You got a lot of time. So you have a choice.
Do